Hi everyone, we'll do today a problem on electric forces. So let's say we have the following given. We have a positive charge, let's say on the x-axis here, and we have another negative charge. Let's place it somewhere down along the y-axis. Negative charge, I'm gonna place it here. All right. And let's say also we have another negative charge at the origin. Let's give those charges some value. For example, this I'm gonna call it Q1, and it's gonna have a value of, let's say, 4 micro coulombs. The negative charge Q2, I'm gonna give it a value of minus 5 micro coulombs. The tested charge, I'm gonna call it Q0, and it's going to be a tested charge because we're going to study the forces or the net force on that charge. Q0 is, let's say it's minus 1 microcoulomb. Q1 is placed, let's say, at x equal 2 centimeters, and the Q2 is placed at y equal, let's say, minus 3 centimeters. And Q0 is at the origin. The question is to find or calculate the net force on Q0, the tested charge Q0, which is the 1 microcoulomb. So we need to find the net force, means we need to find magnitude and direction. So how do we do that? First, we take Q1 with Q0 and we study the effect of Q1 on Q0. Q1 attracts Q0, so the force on Q0 is going to be to the right. Okay, that's, I'm gonna call it F1 because Q1 attracts Q0. Now, we see the effect of Q2 on Q0, since both of them are negative, then Q2 will repel Q0. So the force will be upwards. The force is going to be upwards. That's F2. Okay, I'm gonna elongate F1 a little bit, and you'll see later that F1 will be bigger than F2. Okay, now let's find F1 and F2. So using Coulomb's law, F1 is equal to K. I'm gonna find the magnitude, so I put everything in absolute value. Q1 multiplied by Q0 over the distance between them, R squared. So let's do the math. 9 times 10 power 9. Q1, it's 4 times 10 negative 6. Q0, it's minus 1, it becomes 1. Because it's an absolute value, and the distance between them, it's 2 centimeters, so 2 times 10 negative 2, we change it to meters and we square it. So what will be the value of F1? Use your calculator. So by using the calculator, let me write it here and see what I'm going to get. 9 times 10 power 9 multiplied by 4 multiplied by 10 negative 6 with another 10 negative 6. Okay, times 10 negative 6, and you divide by 2 times 10 negative 2, 20 brackets squared, and you'll get 90. So yeah, we got 90 newtons. That's F1, the magnitude of F1, 90 newtons, and it's to the right, obviously. Now let's find F2. We do the same way as we found F1. Now it's K multiplied by Q2, Q0, divided by the distance, R squared. So 9 times 10 power 9. Q2, it's 5 times 10 negative 6. Because it's an absolute value, it becomes positive. And the Q0, again, it's 1 times 10 negative 6. And we divide by the distance between them, which is 3 now. So it becomes 3 times 10 negative 2 squared. Okay, so let's see what we're going to get here now. So 9 times 10 power 9. Here I have 3 in the denominator, and I have instead of 4, 5. Okay, so we'll get 50. We get 50 newtons. Okay. Now we found F1 and F2. How do we get F net when they have this form? So remember, if you have, this is F1 like that, which is 90, and F2 which is 50, smaller than F1. To find F net, you simply complete the parallelogram here. Okay, like that. And F net will be simply the force between them. That will be F net. Okay, the force between F1 and F2. So how do we find F net? Using Pythagoras theorem. So F net will be square root of F1 squared plus F2 squared. So it's going to be 90 squared plus 50 squared. And let's see what we'll get. 90 squared plus 50 squared. We'll get around 102.9, around 103. 103 newtons. And if we wish to find the direction, you apply the tangent function. That's the angle here, theta. Let's say we want to find theta. So the tangent function, or theta, is equal to tangent inverse of the y component, or F2, over F1, the x component, or the force on the x-axis. And it becomes tangent inverse of F2, which is 50 over 90. And it's going to be tangent inverse of 50 over 90. And it's going to be 29 degrees. 29 degrees. That's direction. 29 degrees along the above the x-axis. 29 degrees above the x-axis. So that's the magnitude, and that's the direction. Thanks for watching.